Hi guys, today we are going to start to operator overloading concept in C++ programming language. Okay, in the previous lesson we have talked about how we're gonna use the constructor overloading, or it means that we can show the total function of the function overloading mechanism in the CPP programming language. But in this lesson, as an object-oriented programming feature, the operator overloading is presented. Okay, and so firstly we need to add the main cpp.file in here, and so I test my code in order to create my main files or main function body in here with pushing the Control F5 button at this time. And so I can select the G++ compiler in here like this one, and then the total VS Code file is created. Okay, and so we can write it down like this one, example 1. And so in the previous lesson we discuss about the structure or total nomination of the class definition in CPP programming language. And so we can divide the two sections, the class A with the definition of the private and public. It means that we can split the whole structure in this class. And so if we can have the A variable with the type of the big A, and so we can create this class structure notation. Okay, and then what? We can write the constructor like this one, a default constructor. Okay, this is a reminder for the lesson. And so we can also define as the int a in here like this one, integer a, int a constructor can be given at this time. Okay, and so we have also a destructor mechanism in here. Okay, destructor endly. Okay, and so we can create this variable by using this phenomena or like this one. Okay, and so if I run this code like this one, and then this redeclaration of a, okay, and so if I run this code, and then the default constructor is called for the what? For this purpose. But in the second place, we can call the int a constructor in the completion process. Okay, and so this is the what? This is the constructor overloading. Okay, it's the basics of the constructor overloading. And this is a reminder section for the previous one. And so we can move to the main subject of this lesson. What about the operator overloading? And so the operator means that like this one, plus plus, plus, minus, or minus minus, or function calling, or array operator like this one. In CPP programming language, we can use these operators in order to manipulate our variables by means of the what? The total calculation, or the summation, or negation, or increasing 1 point, or minus 1 point. Okay, and so what about the overloading? Overloading means that we can use the function func or func integer a, and so the name of these two functions are the same, but its parameters are different. And so CPP programming language codes or notate these whole things as a different address variable on the RAM process or the completion process, and so this is evaluated by a different function, and so this is also a different function as well. Okay, and so the name is same, but what about the operator overloading? Operator overloading means that we can collect all the data or overloading some functions or operations or task into the what operators. Okay, this is the basic definition of the operator overloading mechanism in CPP programming language. Okay, and so how can we show this structure? We can create an example like this one, integer main, and return 0 is passed to the main function. Okay, and so we can create the A class in here like this one with the definition of the private section and public section. Public section means that if we can write or if we have a function under the public section, and so we can use these functions in the main body. Okay, and so we can create a constructor mechanism in here, but we don't need to use that space. Okay, and so a constructor is given by the a constructor mechanism. Okay, and so default destructor is also written a destructor in here. Okay, and so if I run this code, and then the constructor is called, and at the end of this code destructor is calling, but we can also overload the operators in CPP programming language. Okay, but how? You should know that the every operators are defined or evaluated as a function in object-oriented programming, and as well as the C++, because the C++ has a pointer type, but also C++ possesses the object-oriented notation, which means that every variable has both the functions and its variables itself. Okay, and then we can define the operators by using the operator keyword in here like this one, and so we can call the function calling operation in here, and then we can call this function body in here. Operator function calling is here. Okay, this is the example function. You can use or you can write any code in this operator blocks, but if we're gonna define the operator overloading mechanism, we should write the operator keyword like this one, and so the specific operators should be given in the second place, and then we should call this function and define this function by using this notation. And then the basic syntax can be given by the operator and blah 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 blah, or plus operator plus overloaded mathematical notation plus function calling operators. And so you can ask me how we gonna write or how we gonna call this function in here, but it's simple, because if you have this function like this one, a variable with the type of the big A, and so we can call the a variable with this notation. And so you can surprise this notation by looking at or examine this function, but it's totally current in CPP programming language. Okay, and so if we have the pushing by the Control F5 button in here, and so a constructor is called because default constructor construct the whole variable or a RAM location on the CPP programming language. And then what? If we have this kind of information in here, and so this operator function calling is here with the definition of the what? Definition of these terms. Okay, and so we can use this operator like this one, function calling operator like this one, but we can also use the a dot operator in here because this function is defined or was defined in the what? In the class big A. Okay, and so if I call this function, we have twice the operator function calling is here is written on the what? On the terminal page. Okay, this is why, or this how we're gonna use the operator overloading mechanism in CPP programming language. Okay, and so but what is the advantage of using these operator callings or operator overloading mechanism? This is the basic or big question. What's the advantage of usage or using operator overloading in CPP? We have an example in order to explain the advantage of the using of operator overloading in CPP programming language, and so this is indicated by the box class. Okay, and so we can add the using namespace std, and its main function is given at this time. Okay, and so we can create the class box in here like this one. Okay, and so we have the box with the variables of the double length in here, double breadth, and double height. Okay, and so it's a box with a three-dimensional volume space. Okay, and so we're gonna calculate the what? We are gonna calculate the volume of this box or box variables. And so we need to define the public section in here like this one. And so in order to set the proper length and breadth and height value in here, we should define some specific functions like this one, set length. Okay, with the parameter of the double len. Okay, and so this length value is equalized or assigned to the len. Okay, this is the parameter coming from the user, but this length is possessed by the class box. Okay, with the same analogy, we can set the set breadth value, double breadth, and so breadth is assigned to the breadth. Okay, and so we can define the what? The set height value with the what? The double height, and height should be equalized to height. Okay, and also we should give the double get volume value in here like this one, and so return length times breadth times height times. Okay, or we can create a variable like this one, double result value is equal to these things, and so okay, return result is given to the what? To the output of this get volume function. And so we can define the void print volume value like this one, and so cout volume of what? Of box is equal to the what? The get volume value in here. Okay, these are the basic structure of the what? The calculation of the volume value of a box. Okay, and so if we have this kind of boxes, and so box can be defined by this one, box 1, and so box 1 set breadth value to the what? 5 times 5, and so box set height value for 0, and so box 1 set length value 3.0. Okay, and so if we have this kind of information in here, box 1 can be called print volume value like this one, because the print volume value is calculate the total volume by calling what? The get volume function. And so get volume function definition is in here. Okay, and so if I run this code, then volume of box is equal to the what? The 60. Okay, and so we can change the variables like this one, 13, and so 70, and we have the what? 333.45. Okay, and so this is correct. You can check it. And so this is the basic structure of the our algorithms, which coming from the box volume class. Okay, but how we can use the operator overloading mechanism in this notation? Operator overloading. You can assume that, or suppose that, we have two boxes in here like this one. Okay, box 2, and so we can also give the name of this box, box 1, and so box 2, and so we need to write the constructor of this box value in here like this one, and so box string s or s can be given at this time, and so we should add the include value, and so we need to add the string class or cpp file in order to use the string function, and so we should also define the string s or name in here like this one. Okay, and so name can be assigned with the what? The s value. You should remember that the name is equalized to s, but in standard C programming language we cannot assign any characters or character array to the another one, but this equalization operators is called the operator overloading. Okay, because name is a variable of the string class, and so string class possess the equalization operator overloading function, and so the s is assigned to the name in this structure. And so in the volume of box or volume of name can be written in this notation. Okay, and so we can write the box 2 in here, and so box 2 print volume value can be called by this notation. Okay, and so volume of box is equal to 333 ... and so this can be changed with these parameters, and so the difference can be shown by right now. And so the first result is equal to 300 blah blah blah, and second one is 12.75. okay, and so and now our task is to what is to sum both two boxes via operators. In basic maths, we can use the what? We can use the standard structure like this one. Box is equal to the box 3 or box total like this one, and so total box, and so box total is equal to the box 1 plus box 2. okay, because if we have these two boxes in here, and so we can assign this box total by using simple math. But how CPP programming language can know the operation of the plus? Because in order to do that, we should write the total code of this plus operation, which is called the operator overloading mechanism in CPP programming language. okay, and so how can we write this function? Firstly, we should give the box return value, because the box 1 plus box 2 is equal to the what? The box total. And so the return value of this notation is equal to the what, or is in the type of the box. okay, and so we should write the operators in here like this one, and so the plus operator should be overloaded, and so I can give the plus value in here. We should give the function calling operator at this time. okay, this is the overloaded operator, and so this is the definition of the function, but this function is parameterized by the box notation, and so we should give the const box reference b at this time. okay, because this box 2 is the parameter of the box 1 function. okay, this is complex, but it's easy to understand how we're gonna treat this function in here. okay, and so in the expansion form I can give you the box total in the second way in the next lesson. okay, but if we have this kind of operation in here, we can define the box, and so box dot length is equal to this length plus b dot length. This is a special keyword to define or to reach the present class variables, but the b value is the parameters of the what? The box 2 in here. okay, and with the same analogy, breadth should be taken with the what? The plus b dot breadth, and so the box height value, this height value plus b height. okay, and so we can return the box in here like this one. And then what? We now have the what? The total length, total breadth, and total height value, which is coming from the what? These values and these values. okay, and so we can calculate the print volume value in order to analyze the what? The total length, total breadth, and total height value. okay, and so the operator overloading has a huge advantage, because in order to update the total length value, we should set the length, and so the box 1 length plus box 2 length is assigned to the what? The third box value or variables. But if we can use the operator overloading mechanism, this is so simple. With the what? With the plus operation notation, okay? And then what? The box total can be called the print volume value in here. And so if I run this code, and then we have the 3 plus 12 blah blah blah, and so the total volume value of this box is equal to the what? 828.8. okay? This is the basic notation of the what? This class. But in this notation we should write the what? The equalization operators in here, like this one. The box operator equal function calling, and so the operators const box reference b in here, and so this name should be equal to the what? B name, okay? This is the basic notation of the what? The total box notations. And so if we have this kind of information in here, like this one, okay, I'm sorry, void, okay? And so if I run this code, and volume of box is equal to 0, because we overloaded this function like this one. And so b okay, this is not needed in here, but the box name should be equal to this name, okay? And so if we have this kind of operation in here, and so this value is equal to what? The box 1. But we can have this notation like this one, 3 and 1, 3, 2, okay? And so 1, 2, 3, okay? And so if I run this code, and then 6 and 6 is obtained from the what? The box 2 value. But at the end of this code, the total volume is equal to the what? The 48. How can it happen? And so 1 plus 1 is equal to the 2. Or we can write the whole these variables like this one. The height value, name can be given by the height value and leave, and so the other things is also given at this time. Breadth and length can be given at this time, okay? And so if I run this code, okay, cout can be given in order to give the new lines at this time. And so in the first place, the height of box 2, breadth 1 and length 3, okay? 2, 1, 3, and volume of box is 6. But after that operation, we have the 4, 2, 6, and so 4 times 2 is equal to the 8, 8 times 6 is equal to 48. And so the whole operations can be accomplished by using this phenomenon. And so in the object-oriented notation, OOP gives us gives us a way to calculate or to manipulate the class variables, like using the simple math. You see that the box 1 is updated at 3 different variables. Box 2 updates the 3 different variables, and so we can call or we can overload this plus operator, and then we have the volume value and assign to the box totals values. Okay? This is the huge advantage of the of our mechanism to create the object-oriented notations. We can collect the whole class with a simple mathematical notation, plus operation or negation operation, or the times operation or division operation. Okay? And so, what about the volume of box 1 operation? Because this is not true, because the box total name is equal to the total box, but at the end of this code, volume of box 1 is written on the terminal page. This is wrong. Okay? But it is not wrong, because in the first place we have analog code like this one. Box total is equal to the box 1 dot operator plus box 2. Okay? This is the same written operation with the first sentences. They are both the same by seeing in the CPP compiler. And so if I write this code, and then we have the same results in here. Okay? And so this sentence or syntax is the identical or the same with the first one. And then what? This plus operator is translated into the this code phrase. Okay? In where? In the CPP compiler. But we have also another operators in here like this one, and so we can write the whole codes like this one. Okay? And so if I run this code, and then the same results is also obtained from the compiler, and these 3 sentences are identical in in CPP programming language or CPP compilers. Okay? And so, but you can use the box 1 and box 2 by simple plus operator, but the compiler sees this code like this one, because in object-oriented notation every variables is evaluated with both the function and its variable definitions. Okay? This is a huge advantage of object-oriented programming. Okay? This is the first example of how we're gonna use the operator overloading mechanism in C programming or C++ programming language, and then we can move to the another example in here. As an engineer, we can use the complex number in programming language, but the complex number has a problem in their nature, because the complex number cannot be seen in math or in real life. Okay? And so it's not easy to define any complex function in programming language unless you should use MATLAB. Okay? But in object-oriented notation, we can define a specific class in order to create a complex notations or the functions, like the complex multiplication, complex division, and then we can use the complex numbers on the what on C or C++ programming language. And so in order to manipulate our variables with the functions of the plus, negation, or multiplication or division, we should utilize the operator overloading mechanism. Okay? And then, in order to create our example, we should give the iostream with the namespace std, and so as well as the main function body in here. And our aim or our purpose is to create a complex class definition in here, and then we can define every perspectives or every function in the basic math to the what? To the CPP programming language or the compilers. Okay? And so class complex can be written at this time. And so in the private and public section we can define the functions and variables, and then we have two main terms in the complex notation, which means that the double real and double imag or imaginary part of the complex number. Okay? And so in order to create any complex number, we can assign the what? The double real and double I value in here. And so this real value is assigned to R, this imag value is assigned to I. This is not a default constructor, but it's a necessary constructor in this notation. And so we should also give the standard constructor in here. And so these two things or the functions gives us the constructor overloading mechanism. Okay? And so we can create the general functions in here like this one, general functions, and void print numbers, print complex number like this one, see out our complex numbers is equal to the real, this real, and plus I, or this imag. Okay? And endly. Okay? And so we can create the complex number with the definition of comp1, and so 5 4, and complex number comp2 1 2 in here, and comp1 can be called this function, and comp2 can be called this function. Okay? And so if I run this code, the complex number is equal to the what? 5 plus e4 1 plus e2, or in this notation we can create this diagram like this one. Okay? And so if I run this code, okay, plus, and so 5 plus 4i 1 plus 2i. Okay, this is the basic definition of the complex number, and so we can use or we can define this complex number by using simple constructor overloading mechanism. Okay, and then what? We can define the operator overloadings in here like this one. Operator overloading. Okay, and we can create the return type of the complex in here, and so operator plus and complex const reference what the comp number. Okay, and so if I have this notation, we can create the complex res value in here like this one. Res real is equal to the real or this real plus comp num real value. Res imag value is equal to the what? The this imag value plus comp num imag value. Okay, and so return res can be called at this time. Okay, and then what? We can define the new line characters in here, and so the complex comp tree can be initialized with the what? With the comp 1 plus comp 2. Okay, and so comp 3 can be called the print complex number at this time. And so if I run this code and the total summation 5 plus 1 is equal to the 6, 4 plus 2 is equal to the 6. Okay, and so this is not easy, and 5 or 13 and 21, and so the 18 and 25 is the total summation of the complex number. And with the same analogy, we can use this notation like this one, minus operator in here. And so in order to minus these things, real imag and real imag value can be called like this one. And so we can copy off the whole the things for and minus operator can be called in here. Okay, and so if I run this code and minus 8 is the result of the what? Minus or 5 minus 13, and 4 minus 21 is equal to the minus 17 in that code. Okay, this is the basic usage of the how we're gonna use the operator overloading in an advantage way in CPP programming language, because the complex number cannot be defined or easily evaluated by simple syntax in CPP programming language. But by using the operator overloading mechanism, we can simplify the whole the operation on the what? On the main body structures. Okay, and also these functions can be written like this one, the comp1 or this is the same analogy of the operator equal to what? This one, operator plus comp2 is equal to this one. Okay, this is the basic notation of the comp3 value in this notation. Okay, but in order to do that, we should define firstly comp3 like this one. Okay, and so if I call this function, the same result is obtained as well. Okay, in this notation, the copy constructor is called, but it's an advanced topic in that lesson, and so we will remain in these topics in the forward lessons. Okay, and so this diagram is analog with the what? With this code. And so this is how we're gonna use the operator overloading, or how we're gonna build operator overloading mechanism in CPP programming language. Okay, and so operator overloading is the basic stone or cornerstone of the object-oriented programming, because every class, especially in the C# or Python programming language, is built with this diagram. But C++ has a different structure between the what is C# or the Python. C++ is a generalized form of the object-oriented programming because in the Python or the C# notation, we cannot reach the pointers or the basic embedded software techniques. But in CPP programming language, we can reach the object-oriented notation, polymorphism or inheritance, or the what, or overloading mechanism, or operator overloading mechanism. But in C# or Python language, we cannot easily reach these things, operator overloading or constructor overloading, or we cannot reach the pointer types. And so C++, as a result, C++ is a generalized form of the basic cornerstone of the object-oriented programming. I suppose it's the first try or trial to build the object-oriented notation in the history. Okay? And so this lesson is over. I hope you have learned about how to use the operator overloading mechanism in CPP programming language, and have a good day.